こんにちは。Hello.
I'm Keiko and I'm
I'm Mark Kubumatsu.
Inorganic filters are things like zinc oxide.
But when you get a disease, what they love in Russia.
Barbell Radio.
Okay, and hello and thank you for tuning in with Barbell Radio. Today is going to be one of those information-packed, evidence-based kind of episode. Joining me today, I have Sport Physiology Research Associate, Mr. Raymond Wang on the line. Thank you for making the time to be on the show today.
Thank you so much for having me here today.
Thank you. Now, before we get into the topic of our conversation today, please allow me to briefly go through Mr. Wang's educational background. So he graduated from, he has a bachelor's degree in sports science and management from Nanyang Technological University in Singapore, master's degree in exercise physiology from the same university, and he is now currently a PhD candidate at National University of Singapore, specializing in exercise physiology. Now, you might have to dumb down things for me, but what is it specifically that you are focusing on your PhD right now?
Okay, so for my PhD, I'm actually looking at harnessing artificial intelligence and how I can use it to augment human performance. Because I think with the recent years, technology, wearables, and even artificial intelligence has been on the mind of many people. So I would like to use this to try and tap on it, and hopefully we can see promising outcomes on how it can actually improve exercise performance.
Because it sounds very far away from me. Like, what are some of like examples of like how AI is benefiting us in the ways of, you know, exercise and things like that? What are some examples that maybe listeners can kind of
Okay, sure. So how what I'm actually trying to look at is I would like to train the artificial intelligence in creating a training program. So what I did was to try and use the artificial intelligence, tap on it and get it to learn to differentiate the different types of physiological response. And after the learning process, I would use it to create training programs, and I would mainly compare the normal training programs that every average Joes usually use to improve exercise performance, and I compare it together with the exercise training program that is created by the computer or the AI itself, and hopefully you would see if there's any difference between the program that is created by the computer or myself.
Wow. And when you speak about AI, it sounds more like a computer science based field. Like, do you have a lot of knowledge in this specific field, or are you collaborating people who specialize in that field?
Actually, I'm collaborating with other people who is specializing in this field. So my other collaborator, Professor Dean Ho, he's actually an expert in this algorithm. So he used this algorithm to treat many cases of cancer, using drug therapy to improve disease outcomes. So based on his expertise and on his algorithm, I'm actually trying to tap on it to see if we can actually bring it into the realm of exercise science. And I think this is a very niche area that not many people have actually been tapping on. And hopefully we'll be able to see promising results.
Okay. And do you think it's kind of like the kind of similar how you're doing it with exercise science? Do you think it can be maybe incorporated into something like diet and planning for what kind of food you should eat to, you know, achieve some sort of like goal? Do you think, is there like some sort of similarity in those two, like exercise programming and diet?
I think it's going to be a bit different because for diet, it can be quite hard to track some of the macronutrients and stuff like that. But in terms of applying it to many different to some aspects of diet, it could actually be used. Example, some people would actually be taking photos of food, and there are some research that's ongoing where, you know, just by taking the food, the picture can actually be processed by the computer, and the computer will be able to tell you how many how much macronutrients or what is the caloric intake of that food. But it has to be trained very well because different people take photos in different ways, and the AI actually is not that smart yet. So it can be quite challenging to be able to pick out some of these small details that we usually have.
And you must have some sort of limitations as well, because we're talking about each individual humans that are completely different, right? So we all have different, physiological responses, and especially with exercise, people who suffer with injury, like how they're feeling on the day, it must be very hard because there's so many factors are involved. Right.
Yes, exactly. In fact, that is the reason why we decide to tap onto artificial intelligence, is because every individual is unique. And I think by practice, if we will look at the exercise guidelines, everybody would be exercising at the standard about maybe 60% of VO2 just to hopefully see an improvement in your cardiorespiratory fitness. But sometimes we ask ourselves, do we really have to follow it to that same amount? And given that everybody is different, perhaps different people would respond differently. In fact, this has been found in cases where you look at cancer treatment. Different individuals would respond differently to the same dose of cancer treatment drug. And the same could actually be said for exercise as well. So based on this, we actually were able to create a unique profile for every individual. And the AI actually is able to respond to that and create a unique training program just for that individual. And I think this is actually one of the strongest motivation behind our project.
Right. It's just, it's amazing how much the technology has developed, but it also kind of makes me wonder what, for example, people who are coaching or programming, if I don't know, maybe you've heard this a lot, but if AI could do a lot of the things that coaches can do already, do you think in the future, like down the line, that coaches won't really need to be there anymore? Do you think that's a completely different story?
Yeah, I think this is a very common question that I get, because everybody will be telling me, hey, Raymond, if you do this research, you have no jobs in the future. Yeah, but I think it's more of looking at it as how it will complement your training program rather than replacing your role as a coach. So it helps you to make more informed decision rather than applying blanket training programs across all candidates in your team. And I believe this is the case for many of the coaches. They will usually pass down tradition or pass down knowledge based on what they have exposed before, but they wouldn't know whether the same kind of training program would actually benefit their trainees. So perhaps this will help create better inform the coaches on how they could draft out their training program.
So it's more of an aid. And I'm sure there are millions of things that I would be interested in asking even about this topic. But today we'll be putting our focus on one particular topic, and that is muscle protein synthesis, or MPS. And I will hopefully be able to ask a few basic questions around what it is and what is needed to induce MPS and so on. We will then go ahead and cover two studies that compares two common foods that we eat today and how differently they affect MPS. Now, since my listeners on Barbell Radio are involved in some sports or physical activity, they're probably aware or maybe heard of this term, muscle protein synthesis. But for those who are maybe completely new to this, can you maybe give a brief explanation as what muscle protein synthesis means and how it works?
Okay, so we do know that for skeletal muscle, it is constantly being remodeled through a continuous and simultaneous process of both protein synthesis and protein breakdown. And this continuous and simultaneous process of protein synthesis and breakdown sometimes is commonly referred to as protein turnover. So why do we have this turnover? This constant turnover functions to help break down old or damaged proteins and also synthesize new proteins to help maintain protein mass and quality. And the difference between synthesis and breakdown would determine the net protein balance of the skeletal muscle, and it will determine whether you gain or you lose mass.
Okay, so well, you threw in a few words there. Is, for example, muscle protein synthesis differ from the word muscle hypertrophy? Is that the same word, or does muscle protein synthesis lead to hypertrophy? Like, what is the difference between those two words?
So protein synthesis is just a formation of the protein structure itself. So we do know that within a muscle belly, there are many protein structures, and we need this little amino acids to form and create this protein structure, and that itself is protein synthesis. But for muscle hypertrophy, it's actually the gain of muscle mass. Now, if we look at some of our studies, they do indicate that substantial level of protein synthesis would eventually contribute to muscle hypertrophy. So we are looking at is repeated bouts of exercise, and these repeated bouts of exercise stimulates a great amount of muscle protein synthesis, and over time, this build-up actually results in the net gain of the muscle mass, which itself contributes to hypertrophy.
Okay, so you threw in that one of the ways to stimulate muscle protein synthesis, you brought up the keyword of the exercise. What are some of the other ways in which you can induce MPS?
Okay, so we do know that exercise itself can help to increase this muscle protein synthesis, and this would actually be very beneficial for muscle growth itself. Now, what we do also know is that in order to have a positive net balance of muscle protein, we would need to have an exogenous source of amino acids. In other words, we need to ingest amino acids. So resistant exercise and amino acids would provide a synergistic effect, and that would actually produce or create anabolic environment to support growth, or in other words, muscle hypertrophy.
And is exercise a necessary factor then to induce this, or is it just an aid?
Okay, so what actually we found was that exercise itself, and of course with the consumption of dietary amino acids, these two are actually key factors for muscle growth itself. But if we go back to the building block, we need both of them to help to create muscle growth.
Okay, so those two are the absolute key factors. And when you're speaking about exercise, what kind of exercise are we talking of? Because I think you can all interpret differently what exercise is. Exercise could be, for one person, be walking around the block, and for others might be resistance training. What kind of exercise are we talking about?
So it depends upon what kind of protein synthesis are you really looking at with regards to exercise. If you were to perform long enduring exercise, which is a characteristics of aerobic exercise, then you will be producing a lot more of what we term as mitochondrial protein synthesis. But if you were to look at performing resistant exercise, which is high intensity and of course strength-based training, then we'll be developing what we call myofibrillar protein synthesis. So really the kinds of proteins that you develop is really based upon the stimulus that you put on the body.
Right. Okay. And I know we won't go too much into this, but what is you just explained the two different kinds of muscle protein synthesis, mitochondrial and myofibrillar. What are the difference between these two? Is that a hard question for you to cover? Or?
Okay,
It's a
so
big
for
question.
yeah, for the difference between these two is really just in terms of where these structures are placed. So when we talk about mitochondrial protein synthesis, it's really developing the aerobic function of the muscles itself. So the powerhouse of the muscles, which would be your mitochondria. So it's really developing the capacity in that aerobic function. Whereas for myofibrillar protein synthesis, as the name suggests, it's really building the myofibril blocks, which is found in your skeletal muscles. And those are required for force production capacity. Hence, we always talk about how specific exercise would yield specific adaptations.
Okay. And just to maybe tap into something that I'm involved in, which is strength sports, powerlifting. And I am guessing that we do a lot of very high load and not as much. You wouldn't get the idea that people are doing endurance-based kind of training when you're doing powerlifting training. So when you are maybe doing powerlifting specific training, you would be inducing myofibrillar protein synthesis and not as much of a mitochondrial. Or is that something that you can switch on and off, or is it vague?
It's still quite vague, I guess, because there will be instances where the proteins are actually generated, but we won't know for sure. So this domain is actually quite vague in a sense.
Okay. So it's not like one of those.
But I would guess
switches.
that I would guess that there are some studies that looked at how if you were to do more strength-based, there will be a greater chances of you observing changes in the myofibrillar protein synthesis pathways as compared to the mitochondrial extent.
All right. Okay. And I also saw on your on your LinkedIn actually about that on your last year of your bachelor's degree, you did something about protein timing. And I saw that I know this is kind of off the questions, but how you looked at pretty much how protein ingestion timing and how that affects muscular strength and power and endurance. And while we were on the topic of myofibrillar protein synthesis, people, when I started training maybe 5 or 6 years ago, I religiously had to drink a protein shake right after a workout during this quote unquote anabolic window to optimize hypertrophy. But what is your? I'm sure that people will be interested in this. What is your take on this protein timing and?
So with respect to this question, it's with regards to what aspect of performance are you looking at?
Okay. What if it was my muscle hypertrophy?
Okay, so if you look at some of the studies on muscle hypertrophy and protein timing, the key outcome is really looking at hypertrophy itself. And what they found was that regardless of when you take these protein, it doesn't really matter with regards to whether is it delayed or immediate in terms of hypertrophy. Simple reason is because muscle remodeling actually occurs over the span of 24 to 48 hours. So regardless of when you would take it, it doesn't really seem to matter in terms of hypertrophy. Though there are some studies that suggest that the closer you take to the end point of your training, the more sensitive the muscle would be in taking up the amino acids, because the sensitivity of amino acids actually dwindles down as over the course of this 24 to 48 hours. However, in terms of general hypertrophy gains, we don't see a difference, much of a difference in terms of whether you take it immediate or delayed.
It's a mind blown. It's crazy how research has come to because I'm sure that even I think trainees in Japan are still not focused, but believe in this idea or religiously believe in this idea that you have to take protein right after your training or your workout is going to waste. And it's crazy how much, research has developed almost throughout the times. And what about strength? Would that be kind of like the similar thing as well as muscle hypertrophy?
So in terms of strength, performance, and power, not much research has been done in this aspect, so we will know for sure. So what I did back then was I actually looked at how we actually placed the individual on a very simple one-off program, one-day program, where we compared whether if you were to take the protein before, during, or after exercise, would it actually contribute or would it make a difference in the subsequent training program? So I actually put them on a dynamometer, which is essentially testing out their isometric, concentric, and eccentric strength curve. But unfortunately, my sample size wasn't large enough to be able to give some strong results. But there will be avenue for more research in this domain with regards to strength and power contribution.
But as of now, the net, the total of protein ingestion within the 24 hours would probably be more important than if you take protein right after your workout or not.
So what actually happens is if you were to consume typically your food over the span of time within 24 hours, it shouldn't really matter that much.
Okay, yeah, that's a really, really interesting point, I think. And now, just bringing the topic back a little bit, we will be discussing two studies that compares specific foods that we consume in our daily lives. And I think the listeners can relate to some degree that many of us want to build muscle or build as well as lose body fat. And so automatically, I think it makes sense for us to tend to go for foods that are high in protein, but does not have as many calories or in other substrates such as, carbohydrates or fats. And the key word that you spoke about seems to be amino acids or protein. But the question is, do other macronutrients such as carbohydrates and fats have influences on muscle protein synthesis? And the two studies that we are going to pinpoint are going to be studies on that. And and the studies here are actually summed up with graphs and explanations in Raymond's Instagram posts, which I will be linking in the description of this episode. So as well as the full study. So if any listeners are interested, you should go check it out there as well. So the first one is a 2006 study comparing whole milk and skim milk. Can you maybe explain what this study was looking at and what can be interpreted from the findings?
Okay, so this study was generally designed to determine the response of the net muscle protein balance following resistance exercise to ingestions of nutrients as components of milk. So this study actually compared different types of milk. So we have 3 different groups, and the first group would consume the fat-free milk. The second group will consume whole milk. And the third group, it will consume fat-free milk that is isocaloric with the whole milk. So they actually have these 3 comparisons. And the milk, in general, regardless of any of these 3, was ingested 1 hour after the leg resistance exercise routine.
So can you maybe clarify for those what isocaloric means? Maybe people are not sure.
Yeah. So for the isocaloric whole milk in group, what they did was they consumed fat-free milk, but the calories was the same as the whole milk. We know that fat-free milk and whole milk calories, even though they are of the same volume, would differ. So what the authors actually did was a very intelligent way of making sure that the the fat-free milk isocaloric state would be the same calories as the whole milk. So you can actually compare apples to apples in a sense. Yeah. So in this study, what they found was that there are mainly three outcomes that I'd like to bring forth. Firstly, we do know for sure that milk is actually a very suitable product for ingestion during recovery from exercise. Okay. The second takeaway message is that they found that some of the amino acids, specifically taurine or perhaps phenylalanine, okay, the uptake of these amino acids were actually greater for whole milk as compared to the fat-free milk. And these might actually suggest that there are some properties of the whole milk that might help to enhance the uptake of these amino acids. And these amino acids are actually eventually used for muscle protein synthesis. Okay, so the third take-home message is actually perhaps there are some molecules in the whole milk that might actually contribute to increasing this amino acid utilization. So there might be some other nutrients that is available that is found in this whole milk, but not found in the fat-free milk.
Okay, and I think that it's really interesting because a lot of trainees drink low-fat milk for maybe in their protein shakes or something like that in order to hold back their fat or calorie intake, but still try to get same benefits as whole milk in terms of protein. And what this study suggests is that if your main goal is muscle protein synthesis or building muscle pretty much, then drinking full milk may be a better option in regards to building or inducing an MPS. Is that correct?
Yes, that is correct. So this whole milk would actually be more favorable to help improve muscle protein synthesis.
So I think this is just one study, and I'm not sure of how significant it is that if everybody has to switch to whole milk from now on. But how significant is this? Is this like something that we should consider in our daily lives? Are we drinking milk from now on, or?
Yeah, I think this study is actually one of the key studies that suggests that perhaps the cornerstone in developing muscle mass, or what we call muscle growth, perhaps the more important role is actually to look beyond just typical amino acids, but perhaps looking at whole food itself. And I think this has implications because when we look at some of the classic studies in the past where they look at muscle growth, they pretty much just flush the individual with amino acids. But we do know that as athletes, as anybody else, we grow by ingesting whole food. We don't just eat selective amino acids itself. So this really helps us to think about, hey, perhaps in the future for research, we might want to assess the role of food components rather than individual compounds in muscle protein synthesis rates.
Right. And I think this one, you mentioned specific amino acids uptake was higher in whole milk. And those two, I think, were threonine and phenylalanine. Is that
Yes,
is that
that
right?
is correct.
And I've also heard that you need to diverse, like many different kinds of amino acids to effectively induce MPS. Is it just the increase of these two, threonine and phenylalanine, is that a clear indication that just only two of those amino acids, is that a clear indication that it is inducing muscle protein synthesis? I'm sorry, it's a bad question, but I don't know how to put it.
So, okay, no worries. Actually, I roughly get what you mean. So the authors were actually interested in these two amino acids. No doubt, we have a diverse range of amino acids profile in the food. But for the research, for the authors' research, they are more interested in these two amino acids per se, because these two amino acids are essentially tagged. So it's easy for them to track the amino acids movement in the human body.
Right. Okay. That's really interesting. And also it leads us to the second study as well. And the next study were compared the whole egg and just egg whites were compared and how that affects MPS. And this is a 2017 study. This is also a really, really interesting one. Can you maybe explain that as well?
Okay, so in this study, this study is actually, I would find that this study is actually very interesting because it's a follow-up of the previous study. So the previous study looks at milk, and this study looks at egg, because I guess, like you mentioned, these are things that most people would be consuming every day, right? Almost every day.
Yeah.
So for this study aims to compare the whole body and muscle protein metabolic response after the consumption of whole eggs with egg whites. So they actually compared two scenarios where the participants in the study would perform a single bout of training, resistance exercise, and after exercise, they either consume whole eggs or egg whites. So the authors would then measure or analyze the blood and muscle biopsy samples to look at the protein synthetic rates.
And sorry to interrupt. What are the difference? So maybe those who are not aware, what are the difference between these two? Why are we comparing egg whites and whole eggs in the first place?
Okay, so we know that egg whites is just purely 18 grams of protein in this case, whereas the whole eggs would be 18 grams of protein with 17 grams of fat.
Right.
So this study essentially is just, if you break it down to its essence, it's really comparing protein plus fat versus just protein only. Would there be a difference in the myofibrillar protein synthetic rate?
Okay.
So in this study, what they found was that this study was actually one of the first few studies, in fact, to look at ingesting whole eggs compared to egg whites in this young man population. And this study was very smartly designed in a sense where it is isonitrogenous. So what does isonitrogenous means is that the nitrogen compound between these two are actually the same. So you realize that whole eggs is 18 grams of protein, egg whites is also 18 grams of protein, but they only differ because whole eggs has 17 grams of fat.
Right.
And they really show that the whole food would actually demonstrate differential anabolic properties in the skeletal muscle tissue. So this study has many implications. And what they did was they analyzed some of the muscle protein synthetic rate, and they found out three main findings. Firstly, they show that for both these conditions, the muscle amino acid sensing, the amino acid uptake, it did not seem to contribute to the differences observed between the conditions. In other words, it is not the presence of amino acid, it is not the amount of amino acid uptake that contributes to the difference, but rather it is actually the other food component in the yolk itself. Second finding that they found was that the leucine, as we know, which is a key component for muscle building block, is actually the same for these conditions. So it's unlikely that the composition of the amino acids would influence the muscle synthesis rate. So we know that they actually balance out the entire equation, and pretty much they attribute the differences to be found based on perhaps it's the yolk itself. So the third point that they found was that the yolk is actually pretty much a promising area for anabolic properties. In other words, the egg yolk itself consists of microRNAs, vitamins, minerals, lipids, and these molecules have been shown to be beneficial in the transcriptional and translational process of protein development. So in other words, the yolk itself is capable of modulating the muscle protein synthesis rate after food consumption. Yeah. So the implication of this finding is that people have to take their yolks. And I think I think most people are concerned about is the yolks because people are concerned about taking in too much cholesterol, right?
Definitely. That's one of the biggest things, I think. And nowadays, I think it's just recently gotten into Japan, but they sell frozen egg whites now in Japan. And I know in the States, that's like a big thing. You have a carton and you just have egg whites in there and people just buy that and then they consume that instead of consuming whole eggs nowadays. So I think the whole notion of only eat egg whites is a big thing.
Yes, indeed. And I think in this study, what they're trying to advocate is that it is still a popular practice, like you said, to discard the yolk when multiple eggs are consumed. And I think most people, if you see some of them in the gym, they would go to the gym, they would eat their eggs, they would pluck open their eggs, remove the yolk, and just down the egg whites. Yeah. But we do have to know that in this study, they actually highlighted that the yolk itself is a nutrient-dense product, and being an area of high bioactive compounds, the removal of this yolk may actually limit the stimulation of muscle protein synthesis rate. So we do want to suggest that it is not just about consuming enough protein perhaps, but it's also to make sure that we have a well-balanced nutrient and protein-dense food to optimize muscle protein synthesis rate.
And just to go back and clarify one thing about this particular study is that so with the whole eggs and egg whites, the subject took it after resistance training, but they were not isocaloric, but it didn't need to be isocaloric in order to do this experiment because the amino acids or the extra calories were not the reason why it stimulated more muscle protein synthesis, but it was more the content of the yolk itself and the other molecules inside the yolk was what made the difference. Is that correct?
Yes, that is correct. What they found based on previous research is that the extra calories didn't influence the muscle anabolic potential. So regardless whether you consume high calories or not, it did not seem to influence or amplify the anabolic properties of the dietary amino acids.
Okay. And I think this study really covers, it's a really, really interesting finding, but it covers just one thing, and that is the eggs in this particular case. And in order to make this, more broad and, what about other foods? Like, do this same results and concept kind of translate to other foods as well? So eating a protein-dense food compared to energy and protein-dense food, would that translate to the broad spectrum of if you should eat just protein-dense food or whole foods? I think promising, yeah.
So I think what this work really supports is both obtaining nutrient and protein-dense food to meet the daily protein requirements. So I think, like you asked, whether can this be translated to other food sources as well, and I think the answer would be yes. Quite straightforward. Comparison would be most people will, in most research, they like to isolate compounds so that we know that it attributes to that actual source. But in real life practice, not all the time we have the chance to obtain food in these isolated sources. So a typical example would be consuming meat in a sense. So if you talk about animal meat itself, the meat has both proteins and perhaps even fats inside. So I think it's really looking at whole food, and perhaps in the future, further research would really try to highlight and perhaps analyze some of these differences, if there's any, between whole food and isolated food compounds.
And that, nowadays we have, even in Japan, we have this product called Zabasu milk, and it contains 15 grams of protein, but only has, I think, about 100 calories, I believe. And for us, we've never seen anything so convenient, just with the knowledge that we have now. How amazing is it to only consume 100 calories, but still be getting this much protein? And we kind of, just go 100% into this notion of high protein, low calories. And I think these two studies really highlights that that's not exactly the case, and we need to look more into the other foods that we eat as well. So I think it's very interesting in that way. What about have there been other studies that are kind of supporting this idea as well, or?
I think there are some other studies, but I guess this is the more prominent one because of its well-thought design. And I think this is a very smart design in trying to pick out the little details that actually food components are actually key. So this team, led by Nick Bird, and I think for the whole eggs, and the other one would be Kevin Tipton. So these two are prominent researchers that are really exploring this area of whole food compounds as well. So I would think that there will be further research, and there will be more coming up from these teams in trying to pick out whether whole food would be a more promising area to explore.
What are some things that you're maybe interested in finding out? What kind of foods would you think it would be interesting in covering as well? Like what kind of studies and what kind of foods would be interesting? Do you have any of those? I know I put you on the spot, but
yeah, actually that's a very good question. I think most people would be more interested in right now, and I think it's quite an uptrend, is to look at potatoes. Okay, so yes, potatoes. In fact, there are some research being done by Stuart Phillips and his team. They look at potato protein. Okay, because why potato? Because lots of people pops lots of potatoes into their mouth, especially bodybuilders or any typical gym goers. You open up the lunchbox and you find there might be some cases where you will see potatoes. Yeah, so I think. Yeah, so I think this is also one area which I think would be good to follow up. I would also like to look into it and see if there's any promising outcomes on potato protein.
I didn't even know that there was that much protein in potatoes.
Yeah, so I was also quite interested in that area. So yeah, I might actually have a look at some of the findings that they have.
Oh, very interesting. Potatoes. That's really interesting. And maybe just this is now like a super broad question for you, is that and I know you might have to double on the answers of this. Like you've already answered a few of these things as well, but for those wanting to maximize muscle protein synthesis, what are key factors, again, maybe you already explained it to me at the start, to keep in mind?
Okay, so some of the take-home message would be a couple of things. Firstly, would be a look at the amount of essential amino acids that we consume. So if you would like to maximize muscle protein synthesis, then you need to consume sufficient amount of essential amino acids. We are looking at about somewhere between 12 to 15 grams of essential amino acids to maximize and to create a positive net protein balance.
Mhm.
The second part would be to look at consuming the absolute amount of protein. So many research looked at protein doses, and we found that about 20 grams of protein would be important to consume to elicit maximal synthetic response.
Wait, 20 grams at a time?
Yeah, so 20 grams of protein. And in terms of the timing at which how frequent to consume these 20 grams, really is pretty much looking at about 3 to 4 hours apart.
Wow.
That would help to support maximal post-exercise rates of protein synthesis. But what we do need to understand, especially we need to know is that many of this research was done in average weight adults that are 80 to 85 kg. Okay, and I think for us, for Asians, we might actually think that, hey, 80 to 85 kg, how many people would actually fit into this 80 to 85 kg? Is 20 grams, would it be too much? Well, I think 20 grams would be sufficient. If you like to go into the relative to your weight, we are looking at somewhere around 0.24 grams per kg to 0.31 grams per kg. Yeah, so if you find that 20 grams, perhaps you might not be convinced with this number, then perhaps you might want to look at relative protein.
People want to be specific, but it blows my mind that so if you're not consuming this 0.24 grams per kilogram amount of protein at a time, does that mean that it's meaningless? Or I don't understand this. Why you have to drink a specific? Can't you spread out the protein grams throughout the day to make up? I don't know. It kind of blows my mind to know that you have to consume a specific amount.
Yep. So what actually happens is we usually would recommend for athletes to have a high protein meal across the various meals of the day, because what research has found was that most people tend to eat more of their protein in the late evening. Okay.
Right.
You would say that most people would not consume sufficient amount of protein in their breakfast. So we do want to recommend that perhaps this total protein intake can be actually spaced well enough across different meals, and of course to try and maximize your protein intake in your meals as well. So these 20 grams is really a ballpark. It is ready to help you guide your preference as well.
So even if you do consume under that, it doesn't mean that it's a completely meaningless thing.
Yeah, I mean it just means that you need to really space your protein intake well enough.
Right.
Yeah.
Okay, so you covered two things so far, and one is make sure you're consuming enough essential amino acids, and the second one is get at least spread out your protein intake and make sure you're consuming enough protein for your body weight as well. What are some other things is there anything to add to that? What are some things to keep in mind when you want to maximize muscle protein synthesis?
So apart from just eating, I think if you would like to try and grow and pack some muscle mass, resistance training is also very important to take note of, because if you look at the stimulus of the muscles, it's one of the key factors to really developing muscle mass. Not just consuming enough protein, but you also have to work out as well.
Okay, so a lot of balance, and I'm really interested in. I don't know if you know anything about it, but I'm wondering if something like recovery, like sleep, would affect MPS as well. Have you heard anything about that?
Yes, definitely. Sleep has been shown to impact protein synthesis rate, and there are some studies. In fact, this has been quite a recent study by Stuart Phillips and his team, and they found was that sleep is one of the key cornerstones as well. on how it can actually impact protein turnover. So what they found in their study is that if someone has sleep loss, okay, which I think it's quite common in many places, because we don't get enough sleep, especially in times where we get busy with exams, with work. And this sleep loss is actually one of the key factor that influence protein synthesis rates as well. So if you do not get enough sleep, and especially if you do not get enough sleep and you still exercise, what they found was that you don't get a very good improvement in your muscle protein synthesis.
Right. It's pretty much a balance of everything. So not even just eating, but also exercising and everything that we do, and take and think it's normal, like something like sleep and balance between foods as well. What you mentioned in these two studies, like balance between the nutrients in the food is also something that needs to be considered, not just the protein content of those. So I think the key word is almost like balance, right?
Yes, correct. So not just sleep, but we also see that exercise and also the nutrients, nutrition itself, these are actually called cornerstones to improving the health and fitness of an individual.
Right. I think a lot of us likes to go 100% on one thing, and forget the rest. So I think that's a really, really good take home message. And I will be linking the studies and the Instagram posts that you and I interviewed Dylan before on this podcast that you two did together on the post. So I will link that as well. And so Raymond, where can people reach you? Do you have a social media account or?
Yep, you can actually find me on Instagram, Biz Who Lives. You can just reach it out to me and I'll be there as well.
Okay. And any plans on visiting Japan anytime soon after maybe the corona pandemic or?
Japan has always been my favorite place to go to because I love the food there and I really love the people there as well. They are awesome. I really hope that I could actually fly to Japan soon. For holidays. I'm looking so much to it.
Awesome. Okay, so thank you today for making the time to be on this podcast. I was able to gain a lot of knowledge from this. So thank you very much.
Barbell Radio.
Thank you so much for having me.